Today, the topic of my presentation nuclear chemistry. Nuclear chemistry is the subfield of chemistry dealing with radioactivity, nuclear process, and transformation in the nuclei of atom, such as nuclear transmutation and nuclear properties. It is concerned with the properties and changes to atomic nuclei as opposed to traditional chemistry, which involve properties and changes related to the electronic structure of atom and molecule. We will discuss the following subfield: radioactivity, types of radiation, radioactive decay, nuclear reaction, nuclear fission, and nuclear fusion application. Radioactivity. Elements can exist in more than one form. Nucleons to subatomic particle that reside in the nucleus known as proton and neutron. Isotopes differ in number of neutrons only. They are distinguished by their mass number. Uranium with an atomic mass of 233 and atomic number of 92. The number of neutron is found by subtraction of the two numbers nucleate applied to a nucleus with a specified number of protons and neutrons. Radiation. The energy from radioactivity that may take form as a particle, alpha, beta, or as pure energy, gamma. Radiations occur due to the high number of protons and neutrons in atoms. The repulsion of the positive proton causes the unstable nucleus to emit particle to become more stable. Types of radiation. Alpha particle. Alpha particle consists of helium nuclei. When radioactive isotope decay by alpha emission, the nucleus loses two proton and two neutron. Beta radiation. A beta particle is an electron. Since the nucleus does not contain electron, it is though that a beta particle is formed when a neutron split up into a proton and an electron. The proton stays inside the nucleus and the electron is shot out of the nucleus as the beta particles. Gamma rays. High energy radiations are released from an unstable nucleus as it rearranges its particle to give a more stable, lower energy nucleus. High energy photon gamma radiations does not change the mass or atomic number and is represented as gamma. Positron. A positron is a particle that has the same mass as an electron but opposite charge. Radioactive decay. A measure of how quickly a radioactive substance decays is called its half life. Atomic nuclei are said to be unstable when they spontaneously disintegrate. Alpha decay has largest ionizing power, ability to ionize molecule and atoms due to largeness of alpha particle. Ability to penetrate power. Uranium breaks down to form a new elements of thorium as alpha particle. Beta decay. Lower ionizing power than alpha particle but a higher penetration power. Require sheet of metals or thick piece of wood to arrest penetration. Positron decay. An unstable nucleus convert a proton into a neutron and a positron. Gamma radiation. Electromagnetic radiations on unstable nucleus rearrange and emit energy to become more stable. Nuclear reaction. Nuclear reactions involve changes in the nucleus, whereas chemical reactions involve the loss, gain, and sharing of electrons. Different isotopes of the same elements may undergo very different reactions even though an element's isotope all share the same chemical characteristic. Unlike chemical reactions, it is unaffected by temperature, pressure, and the presence of other atom to which the radioactive atom is bonded. In general, nuclear reactions gives off more energy than chemical reaction. Half life. Half life is the time required for one half of a radioisotope nuclei to decay into its product. Example: the half life of strontium 90 is 29 years. If you had 10 gram of strontium 90 today, 29 years from now you would have 5 gram left. Nuclear fission. Many heavier elements with a smaller binding energy per nucleons can decompose into more stable elements that have intermediate mass number and a larger binding energy per nucleons. Sometimes neutrons are also produced. Nuclear fusion. The process of converting very light nuclei into heavier nuclei is also accompanied by the conversion of mass into a larger amount of energy. Application of radioisotopes. Nuclear chemistry has many applications in medicine, agriculture, industry, and research. They greatly improve the day to day quality of our life. Thank you all for the listening to my presentation. Thank you.